So welcome back. Now we're going to do 2.4 Gay-Lussac's law. So as you can see, this one deals with pressure versus temperature. So it says that the pressure of a fixed mass of gas is directly proportional to its Kelvin temperature if the volume is kept constant this time. So volume and number of moles are kept constant, so it's only pressure and temperature that change. And that ratio stays constant, which allows us again to say P1 over T1 is equal to P2 over T2. Whatever factor increases or decreases the pressure, the same factor will be applied to the temperature. And again, when we deal with temperature and gas laws, the temperature has to be in Kelvin. So we take Celsius, the temperature in Celsius, and we add 273 to that. Just like for Charles' law with the volume, we have two similar graphs. So again, we have at 0 degrees Celsius, there is a pressure. You well know in the winter when it's 0 outside, the atmospheric pressure is not 0, right? There is some kind of atmospheric pressure. So if we were to take this graph, let's put it in red, and extend the line, at what line would there be no pressure? It would be, if I were to extend, at minus 273, which equals to 0 degree Kelvin, and that is why we have it in Kelvin at 0. So at 0 degree Kelvin, matter ceases to move, and if there's no movement, there's no collision, and therefore there is no pressure. If we look at the kinetic theory, this one I guess is the easiest to understand. If I heat up the particles start moving faster and faster and faster, and that increases the number of collisions between the particles, therefore increasing the pressure, since the number of collisions is directly responsible for the pressure exerted on the walls of a container, for example. So the last point, very short lesson today, a practice problem. So again, we have here, let's highlight, the gas left in a used aerosol can at a pressure of 100 kilopascal, and it's at 27.0 degrees Celsius. If this can is thrown into a fire, what is the internal pressure of the gas when its temperature reaches 927 degrees Celsius? So what is the pressure? So if I start listing my info, I will have, so P1 is 100 kilopascal. T1 is 27.0 degrees Celsius, which means that this becomes 0.0 Kelvin, right? Like I explained in the last lesson, if I have one decimal, I keep one decimal for the Kelvin. I keep the same exact amount of decimals. For P2, I don't know what that is, so I'm looking for that value. And T2 is equal to 927, which is equal to the temperature. 927 plus 273 is 1200 degree Kelvin. So I have P1 over T1 is equal to P2 over T2, and I replace, so I have 100 over 300.0 is equal to, I don't know what P2 is, but I know that T2 is 1200 Kelvin. So I'll do 100 times 1200 divided by 300.0, and my answer should have three significant figures, and it is 400 kilopascal. There you go. And that's it for Gay-Lussac's law. See you another time for another episode.